Today, I'm delighted to introduce you to a chapter in our research methods known as research design. In the previous class, we were able to introduce to you how problem is defined and how you get from problem up to the design of the research, your research. We went all the way through to where objectives are devised and research questions are formulated. Today, I want to take you to a very, very important part of research methods, namely the research design. This is a blueprint that will help you to get to where you want to go. What is it? What is research design? By definition, the research design refers to the overall strategy that you choose to integrate the different components of the study in a coherent and logical way, thereby ensuring you effectively address the research problem. It's good to note that your research problem determines the type of design you use. A sound research design must have the following. 1, it should identify the research problem clearly and justify its selection. 2, it must review previously published literature associated with the problem area. 3, it must clearly and explicitly specify hypotheses or research questions central to the problem selected. 4thly, it should effectively describe the data which will be necessary for an adequate test of the hypothesis and explain how such data will be obtained. And 5thly, describe the methods of analysis which will be applied to the data in determining whether or not the hypotheses are true or false. So those are the preconditions that a good research design must have, and it is very important. Like any building, these engineers normally talk of the blueprint. Any building must have a blueprint. It is the blueprint that helps the builder to know the type of building and the type of materials that need to be put together to produce that building. A research design is such a thing. There are two broad types of research designs, quantitative and qualitative. Today's lecture, we will only deal with the quantitative design, and then in the consequent class, we will handle the qualitative design. This is a conceptual view of what the quantitative research designs look like. The quantitative research design is divided into three, what we call the experimental design, the quasi-experimental design, and the non-experimental design. I'll describe that later. The non-experimental design is divided into three parts: the descriptive design, the correlational design, and the predictive design. So we'll start to help you understand how each of these, what this means, what each of these quantitative research design means, and what it incorporates. experimental research designs. This is used, experimental design is used where, one, time is involved. So you know that a cause precedes an effect in a causal relationship. A happens before B takes place. So there's a time in between A occurring and the time in which B is influenced or is affected. So there's a time in between there. Secondly, there is a consistency in causal relationship, that a cause will always lead to the same effect. Consistency. You slap me on one cheek, I will turn the other cheek for you to slap. You come tomorrow, slap me on one cheek, I will turn for you the second cheek to slap. And so on and so on. So there is consistency. You do A, you get B. You do A, you get B. And so on and so on. And thirdly is the magnitude of the correlation is great. Before you do an experimental design, you must have some background knowledge that there is correlation between those variables that you want to experiment on. The classic experimental design specifies an experimental group and a control group. The independent variable is administered to the experimental group and not to the control group. And both groups are measured on the same independent variable. So you basically get a population. You can decide to divide that population into two parts. One part, you administer a treatment. The other part, you don't. And then later on at the end, you come and compare this group that received a treatment. Do they have a different effect as opposed to the other group that never received a treatment? If it is, then you'll know that A causes B. So that is an experimental. There is the control group and the experimental group. So the subsequent experimental designs have used more groups and more measurements over longer periods. And true experiments must have the control group, must use randomization, and must use manipulation. That is the definition of experiment. It must have a control. Whatever you do to one group, you don't do to the other group, so that you see the effect of what you have done to one group. If you are treating it, like now we have coronavirus. If you want to know that coronavirus is effective, coronavirus vaccine, whatever is effective, you divide the population into two groups. One group, you give the vaccine, the other group, you don't. And then after some time, you can again subject them to corona infection, and then you see whether the group that was treated or given the vaccine doesn't catch corona, as opposed to the group that was not treated. If you find the group that was treated doesn't catch corona, then you know that that vaccine is effective. And the terminology randomization means that the people you put in either the experiment group or in the control group, you pick them randomly. You don't choose. If you decide to choose only healthy people and put in group A and the sick people in group B, that is not randomization. And so that will not work. And thirdly, there is this manipulation. There must be an action, and if a treatment, you must manipulate. You put a treatment You give a treatment, and that is what we call manipulation. What does experimental design tell us? One, it allows the researcher to control the situation, and in doing so, it allows the researcher to answer the question, what causes something to occur? That's a very, very important question. What causes B? What causes B to behave the way it behaves? Okay, so that is very important. Secondly, it permits the researcher to identify the cause and effect relationship between the variables to distinguish placebo effects from treatment effects. In medicine, actually, like the example I've just given with coronavirus vaccine, the experimental group can be given a real vaccine, and the other group is given placebo. Something similar to a vaccine, but it does not have the vaccine in it. So that the other group doesn't think that they are being sidelined. So that's what we call a placebo. Placebo effect and the treatment effect. So experimental design also, thirdly, supports the ability to limit alternative explanations and to infer direct causal relationship in the study. Once you do an experiment, you can be able, with confidence, to say A causes B, A influences B, without doubt, as opposed to other designs where you just speculate. With the experiment, you can be sure to say A causes B because I treated in my experimental group, I give a treatment. In the other group, the control group, I did not give a treatment. The one with treatment, I saw the impact. The one without treatment, there was no impact. So you can be able to say with a lot of confidence that the relationship A causes B. And finally, number 4, it provides the highest level of evidence for single studies. If you do a single study, you can be sure to say A causes B. Having done this experimental design, we now go to the quasi-experimental design. What is quasi-experimental design? It involves the manipulation of an independent variable without the random assignment of participants to conditions or orders of conditions. It is called quasi because one element that was in the experimental design is missing, the randomization. You don't put people randomly in the group, control group and experiment group. You can biasly put them there. Once you biasly put them there, that is called quasi-experimental design. The same things. I mean, the treatment is given. The only problem is that you didn't do random assignments to the group. Like I've just said, if you put only healthy people in group A and sick people in group B, and then you treat the group A, or even treat the group B and don't treat group A, already there is a bias because the groups were not identical. Example, when you have non-equivalent group design, you can hypothesize that a new after-school program will lead to higher grades. So you choose 2 similar groups of children who attend different schools, one of which implements the new program, the other does not. So the issue here is the groups are not similar. The groups are not similar in the sense that they attend different schools, and yet you are giving a similar treatment. So the new after-school program will lead to higher grades. So you choose 2 similar groups of children who attend different schools, one of which implements the new program, the other does not. So that alone is, there are some other effects that can cause the change. Because they don't attend the same school, they don't have the same teachers, the environment is not the same, the facility is not the same. So that is not random. That is not random. And the groups are not similar. So quasi-experiments are studies that aim to evaluate interventions, but that do not use randomization. So similar to randomized trials, quasi-experiments aim to demonstrate causality between an intervention and an outcome. That's the intention, but only that the method is not similar. So this will be our last consideration, what we call the non-experimental designs. Non-experimental designs. There are three types of non-experimental designs: the descriptive, the correlational, and the predictive designs. Now we'll look at each of these in turn. What is a descriptive research design? This is used to describe characteristics of a population or a phenomena being studied. It does not answer questions about how or when or why the characteristic occurred. Rather, it addresses the what question. Excuse me. So, in descriptive research design, you're only able to explain what or describe what you see. This phenomena is like this. This phenomena is like this. What causes it, you don't know, but you're just describing. The man is short. The man is tall. The man is yellow. The man is orange. And so on and so on. You just describe the phenomena. And you can be able to tell that this population we studied is characterized as follows. But you don't know why. Why are they yellow? Why are they orange? Why are they short? Why are they tall? Descriptive research design does not give you an answer why they are tall. Why are they short? It doesn't give you that answer. It only tells you they are short. 90% of the people are short. 80% of the people are yellow, but doesn't tell you why. So, descriptive research generally precedes explanatory research. So, of course, it's important to explain why something happens or why something is the way it is. That's why you need an explanatory research to be able to explain what you see. An example here is to overcome the periodic table's description of the elements over time, the periodic table's description of the elements allowed scientists to explain chemical reactions and to make sound prediction when elements were combined. Long time ago, somebody discovered the periodic table in chemistry. And at that point, they were only able to describe the table. But over time, after describing the table and the elements in the table, later on, scientists were able to explain the chemical reaction, and then they were able to make sound prediction. When two elements are combined, what happens? The description is the stepping stone eventually for explanation. That's why you need to do descriptive studies to help you move to the next level of analytical study or explanatory study. So another example is an attire brand. An attire brand that wants to understand the fashion purchasing trends among Gulu city dwellers. Someone can conduct a demographic survey of this region, gather the population data, and then conduct a descriptive research on this demographic segment. You bring whatever you bring. If you bring, there's something we used to call, there's another we used to call belly bottoms. Those were the days of the 60s and 70s, belly bottoms. And then there was something we used to call marks for women, very long dresses that go up to the ground. If, for example, now you begin to produce marks and you bring the Max brand to the people in Gulu, then you see their buying behavior. Then you can be able to describe how they buy, how is their reaction to Max among the population. You can only be able to describe how they react, but you cannot explain why they react that way. That is a descriptive research design. Thereafter, there's what we call the correlational research design. What is correlational research design? This design measures a relationship between two variables without the researcher controlling either of them. It aims to find out whether there is a positive correlation, where both variables change in the same direction, or a negative correlation, where both variables change in the opposite direction, or where there is no correlation. Simply, normally you cannot do correlation by observing. You cannot do correlation by just feeling. You can only do correlation by using a software, a spreadsheet software, SPSS, Stata, and other software that can be able, because you need data. You need quantitative data for X and quantitative data for Y before you can be able to analyze whether X and Y are correlated. So this is a quantitative research method. Correlational research enables researchers to establish the statistical pattern between two seemingly interconnected variables. As such, it is the starting point for any type of research. It allows you to link two variables by observing their behaviors in the most natural state. So at first, there must be a guess that these two variables are related, but you don't know how far they are related, in which direction do they move when they get together, when they come together, what is the magnitude of the correlation. So once you collect the data on the two variables, like normally, some people say, well, the more you spend on advertising, the more sales you can make. The more you spend on advertising, the more sales you can make. So spending on advertising can be one variable, call it X. And then the sales you make, sales volume, is the other variable, call it Y. So if you collect data over time, maybe every week, every month, or even every day, then you can be able to take this data on expenditure, on advertising, and then you correlate it with data on amount of sales volume you get. When you do that, you can either get positive correlation, or in a rare circumstances, you can get negative correlation. And if you get no correlation, it's also a valid judge, a valid outcome. So, predictive design. This is the third of the non-experimental designs we've been considered, predictive design. What is this? It is the empirical research concerned with the forecasting future events or behavior. The assessment of the variable at one point in time, it is the assessment of the variable at one point in time so as to predict phenomena assessed at a later point in time. It's about prediction. You'll study the variables today And then you use the results to predict. If today the growth is 5%, you can predict that in the following year it will also grow by 5%, or it can grow by 7%. You can predict, but the prediction can only be done when you have done some good observation. And you can be able to say, the way the trends are, I predict that the following year or the following 2 years, we shall get such a growth rate. An example, a researcher might collect high school data, such as grades, extracurricular activities, teacher evaluations, advanced courses taken, and standardized test scores in order to predict college success measures such as GPA at graduation, or awards received, or likelihood of pursuing further studies. Once you have the data, like we have just said, class grades, what students score. When you look at the monthly scores, and then you look at what they do outside class, and you look at their teachers' performance, and look at the courses they take, and look at these scores and that score, you can be able to predict that this kind of students will get higher grade at the university. At the end of their course, they will be able to score a first class or an upper second class. That is prediction. So this is the end of our class for today. The next class we shall be looking at the qualitative research designs. I encourage you to follow up this with some reading, and also if you have questions, kindly put your questions together. I'll be available later. And we are going to post this work on the e-learning platform, and you'll be able to follow it up. I'll be setting some questions to guide you in the revision, and also to guide you in further reading. Now, I expected you to continue developing your concept. The more you think through your concept, even in line with what we have just looked at under research design, the better for you. So see you soon. The emails are open, and you can also send me messages through WhatsApp and other means that you have, including the e-learning platform. There are SMS opportunities there. You can use it. Let's keep in touch. All the best. God bless.